Hello everyone, welcome to the equation lab. Today we will be doing one arithmetic problem. So let's start with the question. So today's question will be a Pell-like equation. Pell's equation is an equation where it is in the form x squared minus ny squared equals 1. So our question will be a little different from that form, but it will be the same like topic. And this is a little bit more advanced than what I have previously covered. So today's question is, find all integers x comma y satisfying x squared minus 5y squared is equal to 4. This is basically in the form of Pell's equation, but it isn't equal to 1, so we'll have to figure that out. And yeah, I'll give you guys some time to solve this out. So now let's plug in y is equal to 0 and y is equal to 1 into this equation and solve for x, so we can get a couple of solutions for our equation. So we get solutions 2 comma 0 and 3 comma 1. Remember that all of these can be negative, like it could be negative 3 comma 1 because our solution had to the power of 2 in it, and a squared number is always positive. So negative 3 squared is 9, 3 squared is 9. So we will use recurrence formulas to find the solution to our question. And the base of that recurrence formula is going to be in the form x plus y root 5 over 2. So for example, we had the solution 3 comma negative 1. We could plug that in to get our base, and that would be 3 plus root 5 over 2. So then we get this if we multiply both of those. We get 3x plus 5y plus x plus 3y times root 5 over 4. And if we rearrange it and we put a 1/2 on both of those and put a 1/2 in the denominator, we get basically the same form that we had for our base. So we got our recurrence formulas from that. And from these, we know that the term after the solution that we have is 3 times the x plus 5 times the y over 2 for the x, and x plus 3 times the y over 2 for the y. So for example, if we take our solution 3 comma 1 and we plug it in, we will get the solution after that in the equation, which would be 7 comma 3. So this is another way we can write this, that x of n is equal to L of 2n and y is equal to f of 2n. L and f are two sequences. L is the Lucas number and f is Fibonacci numbers, or the Fibonacci sequence. In both of these sequences, you add the last two terms to get the current term. So if the last two terms are 1 and 2, for example, you would write 3 as the current term. So if we plug in 0, we can get that the 0th Lucas number is 2, and the 0th Fibonacci number is 0. And 2 comma 0 was one of our solutions before. If we plug in 1, we get 3 comma 1, which is also one of our previous solutions. So that is where this comes in to play. So then this is another way we can write it. This would be a way to write the recursion formula. And we get the base, we knew the base was 3 plus root 5 over 2. We plug in 3 comma 1. And then we do the same, just minus on the other term, and we can add them to get this. So y of n is very similar. You just multiply what we had before times 1 over root 5 and make the term subtract. So this way is very long, so I wouldn't recommend it. I would recommend using the other two, the ways to find solutions. But you can use whatever you want, whatever you understand, because you just need to find the solution. That's literally it. You can find it in any way you want. So we know that the solutions are going to be in the form plus or minus x of n and plus or minus y of n, because since there was a squared in our equation, we can have plus or minus and it doesn't matter. And finally, the solution to our equation. So as we saw with all of the solutions, or the ways to find the solutions, you can literally have as many solutions as you want. There are infinitely many integer solutions for this equation. because you could get the biggest numbers and still have like a solution, and you could also have the smallest numbers like 2 comma 0. So our question was, find all integers x comma y satisfying x squared minus 5y squared is equal to 4. This question has infinitely many integer solutions. Thank you for watching, and make sure to like and subscribe.